Good morning, ladies and gentlemen. Here is a solution for a wonderful group theory question. I've decided to name this exercise The Beast. Arnold's curious about what's about to happen. All right, so this is from the exercises that Mr. Becker sent out to you. It's a 32-mark question. Lengthy. This would be half of the option right here. And this would be a moment to celebrate because if this exercise showed up, we know how to do all of this. We don't have to worry about anything else. So let me get this thing to actually go to the first page of the question and we'll begin the solution. The binary operator star is defined for AB element of the reals such that A star B equals A plus B minus AB. We need to show that star is associative, determine an identity element, determine the general inverse for A. Ooh, that's too thick. And showing that the inverse exists for all values of A except for 1. Then we need to solve this equation. This should not take us 15 minutes, so let's begin. Remember the construction of our argument to demonstrate associativity. We're going to consider 3 elements. We'll consider A, B, C, all from the same set, which in this case, real numbers. And we're going to consider a binary operator star such that A star B equals the sum of the first element and the second element minus the product of the two elements. We are going to look at 2 setups because associativity measures whether there is a difference in how we group the elements when operating. So this will produce A plus B minus AB star C, which will be the first element plus the second element minus the product of the two elements. I'm going to go ahead and distribute while I'm at it. So I've skipped a step. This one will have A star B star C, which is B plus C minus BC. Oops. Which is the first plus the second minus the product of the two. Once again, I'm skipping a step and distributing the A at once. A plus B plus C minus AB minus AC plus BC. Whoa. Let's see what happened here. Why did I put... Oh, silly me. And silly me here. That's what I get for trying to skip a step. Now, a question you may be asking is, well, maybe it's not associative. It has to be. It says show. So this is going to be A plus B minus AB minus AC minus BC plus ABC. And this one, A plus B plus C minus BC minus AB minus AC plus ABC. All right, the world is at peace. Now we're good. So we can say since A star B star C equals A star quantity B star C, star is associative. Part 2I, find the identity elements. Identity element satisfies A star E equals E star A equals A for all A element of the set we're interested in. So I'm going to just set up an equation. We're going to just consider some elements. We'll consider some element x and a, and we're going to set up the equation a star x equals a. We're looking for an x that satisfies this equation, and possibly that's going to be my identity. This would result in a plus x minus ax equals a. The a's destroy. I can factor. I'm left with x multiplied by 1 minus a equals 0. So by the ZPP, yeah, you know me, we can say that x equals 0. Now, we're not sure that this is our identity. This is our suspect. If I have previously proven commutativity, I'd be done. But I haven't. So now we're going to actually substitute into this part of the equation. 0 star a, hopefully this gives us a, is 0 plus a minus 0 times a. Wait, look at that. That goes away. We're left with a, check. So that means that e sub star equals 0. We're going to move to a new page for number 3. Give this a few moments. There it is. All right. Find the inverse of a element of the real. So we're going to just consider two elements, a and b. And we're going to set up the equation a star b equal the identity. And we're trying to solve for b that satisfies this. So we get a plus b minus ab equals 0. I'm solving for b, so I'll kick the a over to the right side, factor, and divide. So I'm skipping a step here up to double equal. I love those. So I'm going to go over here and say, this is my suspect. We're going to look at b star a, and if this is actually the identity or the inverse element, then b star a should also give me 0. Negative a over 1 minus a plus a minus the product of negative a over 1 minus a. This is going to be negative a over 1 minus a plus, I'll go ahead and create a common denominator. A minus a squared, and this will be plus a squared. That destroys, I'm left with 0. Check. So I can say, therefore, the inverse of a is equal to negative a over 1 minus a for all a element of the reals except for a equals 1. So I could say, therefore, 1 inverse does not exist. So we're going to solve x star x equals 1, or x squared equals 1. So we're trying to solve for x that satisfies this equation. You may be tempted to bring everything to one side and to find difference of squares. Let's see what happens. So x star x equals 1. I can multiply both sides by the inverse of x. So I'll say x inverse star x equals x inverse star 1. What happens here when since we've already, I guess this is important to say, this is actually what we have right now. We actually have this. We've proven that star is associative. That allows me to say that I can regroup them in this way. So what happens here? This is going to be the identity element, which is 0. So this becomes 0 star x equals x inverse star 1.